my name is Mohammadreza, and my nickname is Momo because the pronunciation of Persian names a little bit, and the combined names like Amir, Hussein, Mohammadreza, etc. is a little bit challenging for the foreigners. I got this nickname during my stay in the States during my PhD that I left Iran for my PhD. First to Switzerland, EMPA, that I had my PhD thesis at EMPA in St. Gallen in Switzerland with Rudolf Hafenus, who is known in fiber melt spinning. And after that, I had also a 1.5 year research visit at North Carolina State University in America, in Raleigh, NC State. And after completing my PhD, I back to Iran, and I worked as an assistant professor at Razi University while my studying university for my bachelor and master was Isfahan University of Technology, IUT. And at Razi, I worked for 5 years as an assistant professor. And and after this period of time, I got an offer for postdoc in Aachen, RWTH Aachen, RWTH, with Professor Glaze. And I started my postdoc over there in 2021. And I had 1 year of postdoc through Theodor von Karaman Research Fellowship, which was from the university. I worked on fiber melt spinning again. That was my expertise back to my PhD thesis and also activities in Iran for installation of BCF machines or FTY machines and so on. And I worked on polymer optical fibers. And during this period of time, I got a job offer from Senbis Polymer Innovations, and I moved to the Netherlands to start my career here as a project manager. And since September 2022, I'm working at Senbis as an R&D project manager. At the same time, I applied for European funding, Marie Curie Research Fellowship for postdoc. That I got that funding, and at the same time, I'm a researcher or Marie Curie Research Fellow from Brussels, from Europe Commission at Senbis, which is now, I think, after 3 months is over, and I need to report to Europe Commission. During this almost 2.5 year stay at Senbis, I was coordinating several commercial projects for the customers, third-party customers, big companies, small startups, etc., to convert their polymers to fibers through melt spinning. It could be biodegradable polymer, bio-based polymers or biopolymers, recycled polymers, and so on, which is the core activity of Senbis to provide R&D service to the third-party customers. And this is almost our 50% of capacity, Senbis Polymer Innovations. And we have also other activity which goes through our sister companies, Senbis Sustainable Products, that we work on the developments of our own products, which are all of them biodegradable. That is following our mission, which is tackling microplastics and having a better future and sustainable products for our society. This is the two core businesses of Senbis that I'm trying to involve in both with my research and academic background and also networking capability and so on. Now, especially in Europe, sustainability is very highlighted. Even for the companies, they always try to promote their sustainable products. From the subsidy perspectives, Europe Commission and a lot of investors and so on, they want to promote or support or subsidize the sustainability approach, even in case of R&D and research work, in case of innovation and product development, and also production. And sustainability has different meanings. Like some people, they try to claim on carbon footprint or LCA that replacing of a bio-based or CO2 based products, or in front yeah, in the front is plastics with the fossil based plastics, which bio-based. But in our perspective, only being bio-based is not enough. We are trying to make biodegradable plastics. And according to European Bioplastics, which conference was last week, biopolymers or bioplastics has two categories. They can be bio-based, regardless of being biodegradable, or they can be biodegradable regardless of being bio-based. That means even a polymer is biodegradable, we can name it bioplastics. Even PCL, which is polycaprolactone, which is fossil-based, but is biodegradable. But we have also polymers like PLA or PHAs that are both bio-based and biodegradable, which are, I think, better for the applications. Our main and this in this route of sustainability, textiles play a very important role, because most of the microplastics come from textile base, especially in the marine environment. That is the first rank with 35% or even more contribution in the microplastics. And the shedding of fibers, which the main fiber in the market is polyester, which is not biodegradable. We want to replace it with biodegradable, and better to be even bio-based, like PLA, PHAs, and so on. This is our first target for this, and Europe Commission also supports that, and a lot of directives and policies and so on is coming out for to support these kind of activities. During the last 20 years, I think polyester had the highest growth in the market, and I think it's because of the availability of monomers. The huge infrastructures are built up with the companies like Indorama or other companies, big names, and now today polyester has 60 million tons of polymer for fiber market and 20 million tons for bottle industry, and the steel fibers are larger. And this can attribute it to two aspects. First is the performance, and second is the price. But I would say in the textile market, I would say price is very important, because we all know polyamide 6 and 6-zig, especially 6-zig, has much more better performance for water, for moisture absorption, for resiliency, for the peeling resistance, and so on. But polyester is very successful, and I think price plays a very important role in this aspect. According to the statistics, like from the Statistica, which is the reports, and also Nova Institutes and so on, these kind of market reports and informations, the information is showing that during the even last 20 years, natural fibers, they were almost the same. Like cotton was always around 20 million tons per year, not too much difference and so on, not grow. And because this is clear that you have limited lands for growing cotton, you have water consumption and so on, and you cannot really expect a lot of differences and so on. But polyester, between around 100 million tons of man-made fibers, that viscose, nylon, etc., they are also there. Polyester had much more increase and increase in production from, I think the last year it was 60 million tons. That means 57% of total fibers in the market. Of course, this establishment and replacing that with just another alternative that has the same performance, the same textile hand feel and combination with wool, with cotton is not easy. And but in case of sustainability, a lot of companies, fashion brands, etc., they are more interested to use recycled polyester. Not even recycled, circular. That means from the same source. That means textile to textile. Of course, bottle is polyester bottles are the most clean material source for recycling, but they are promoting textile recycled. That means polyester, in which the chemical recycling is the best approach for that. And they are trying also to push for the thermomechanical recycling of polyester fibers to polyester fibers. Chemical recycling recycling, and in front is the thermomechanical, and then chemical recycling is the first approach. And the second is bio-based polyesters. That means a lot of companies, they are trying to make terephthalic acid and ethylene glycol, especially ethylene glycol from biosources. This is the second approach, but our approach is to find even biodegradable alternative for polyester, but the same polycondensation way, the same platforms, infrastructures, but only the end of life is more cleaner and environmental friendly. I think this is very highlighted. The remarks that you made is that not only polymer and the material, and not only the fiber shedding that they are trying to reduce that, but also the chemical process, the dyeing and the dye stuff that they use, the wastewater, etc. These are making textile industry very harmful and polluting for the environment. And there are many associations that they are trying to find a solution for maybe all or maybe one of these sectors, like the microfiber consortium is trying to prevent fiber shedding first, and also to study the harmful effects of additives and chemicals, dyes and so on, like dispersed dyes, etc. And if we compare polyester compared to the other natural fibers or man-made fibers, polyester has good properties. Yes, we agree on that. But on the other hand, it has dispersed dyes, which need a lot of energy for dyeing. The waste is not really, the wastewater is not really environmental friendly and so on. And a lot of companies, they are trying to find a solution for one process. Our company is trying to find for the polymer and for the fibers. But there are other companies, they are trying to find, I know a lot of companies, they develop natural dyes for polyester. They are making much more energy saving and sustainable process for the dyeing and so on. But of course, finding a fiber is not the only step. You need to find the right dye for that. You need to claim, you need to prove that the fiber fragments, and also the residues of the dyes is not harmful, is not toxic for the soil, for the marine environment, and so on. And this is the textile value chain that a lot of associations are going to be built up to help each other in this process to tackle this issue, especially microplastics. There are also some barriers for replacing a more sustainable fiber for polyester. And this is a clear reason that a lot of fashion brands, they don't like to move from polyester to another fiber. And the first one that I mentioned already is the price. And the price is a driven factor. And polyester fibers now they buy, I think, around 2 euros per kg. And of course, there are also yarns like DTY yarns, special yarns that they can go up to 10 euros per kg. But the price is the first reason. Second is the performance, and they want a textile performance and touch fiber. Can be combined with cotton and wool. Comfortable and also durable. And actually, this durability or service life is not in agreement always with the biodegradation. Because you have a biodegradable fiber, that means you will have disintegration at the beginning. And I need to clarify also, biodegradation doesn't mean just breaking down. It means conversion of polymer with the microorganisms to CO2 or CH4, which is aerobic and anaerobic biodegradation. And for biodegradation, we need disintegration. That means breaking down to the small fragments or oligomers and so on, which can be via enzymatic or abiotic hydrolysis. But when you have disintegration, that means you are losing your mechanical properties. And a lot of biodegradable polymers at the beginning, even they have less mechanical properties, but there are also biopolymers like PLA that they have high mechanical properties. But we need to choose between a better end of life or durability and so on, or find a solution that we can have both. That's the reason that we are trying. Our company has several projects, and at one of the biggest one is the biotech, that we are trying to find biopolyester. That means alternative polyester, which is bio-based and biodegradable, but with the same performance as polyester. And the second one is compounding and developing new recipes to fulfill biodegradation. And actually, my Marie Curie project was to understand the correlation between chemical structure of the polymers like PLA, PHA, PCl, PBS, PBAT, which are biodegradable, with the processing parameters to make fibers like drawing ratio, crystallization temperature, and so on. And also environmental factors to study the mechanical properties of the fibers and yarns and biodegradation rate to see how they can change. And you see different aspects for different biodegradable polymers. And having all of them at the same time is not possible. But we are trying to have the optimized conditions with developing new recipes and new biopolymers. But about the fashion brands, I think the price and durability and performance is very important. And they prefer first recycled, second bio-based, and then at the end maybe biodegradable. But I think the new regulations, especially in Europe, will change the route during the 3 or 4 years later, because already there are a lot of legislations for some other applications like infill, artificial grass, etc., to make them biodegradable. First bio-based, and then now they are pushing for biodegradable. And PHAs, actually, they are very interesting polymers because they are bio-based. Not only bio-based, they are made by bacteria, they are biodegradable, but they have a lot of challenges for making fibers out of it. And the price would not be cheap, but if the big names, they move for making the polymer in larger scales, the price will drop. And one of the reasons for polyester, which is cheap, is that the production is in large scales. And imagine PEF, polyethylene furanate, that is a replacement for polyester for packaging and barrier applications, which is developed by some companies that they are known. I'm not mentioning the names, but the price is not cheap. But when they start to make in larger scales, I think the price will drop to the same or even 50% higher than polyester. But that polymer is only bio-based. There is no proof that is biodegradable. But there are a lot of proofs that PLA is biodegradable. But biodegradable, in case of certifications, should be in a specific time frame. But no persistence microplastics means it's biodegradable, but maybe in 20 years in the marine environment or soil. That's the reason that from the certificate perspective, PLA is known as only industrial compostable. But in theory, it can be biodegradable in any environment. So far, there are two main goals that is under consideration by the plastic companies and also fashion brands and so on. The first one is the LCA, or the global warming, that the target is by 2050 to be zero carbon. And in this scope, the carbon negative materials and bio-based polymers, and especially by the report by Nova Institute showing that CO2 based polymers, that you are using CO2 from the air to make a polymer that is carbon negative, will play a vital role. And another approach is the microplastics, that within the whole environment, soil, wastewater, and marine is the main scope and main focus. That textile fibers, again, they are under consideration because 35% of microplastics, that every year less than around 1 million ton of plastics go into the marine environments. And 1 million ton is enough for filling one stadium, football stadium, big, with the plastics pallets. And these are the two approaches. And I hope the textile value chain, these associations and new developments, especially with the biodegradable plastics, bio-based plastics, will help to achieve these milestones and these targets. Yeah.